This lesson will be an introduction to the process for solving inequalities. But before we can discuss the process, we need to make sure that we remember the symbols and what they actually mean. So the first inequality symbol that we are going to review is the less than symbol. And the less than symbol looks like this. The next one that we're going to be using in this lesson is greater than. Greater than symbol points in this direction. The third symbol that we're going to review is less than or equal to. So it looks just like the first one we drew, but it also has a line underneath. And the fourth one, greater than or equal to, looks like the greater than symbol, but also has a line underneath. So if you forget what any of these symbols mean, either during this video or as you're doing practice problems for tonight's homework or tomorrow in class, please make sure that you remember you can always refer back to this page. The majority of this lesson will consist of solving inequalities, but before we can get to that, we need to discuss how to plot inequalities on a number line. Because when you find your solution after doing the solving process, you're always going to be asked to plot your solution on a number line. So I want to discuss a few of those first. So if we look at this first example here in green, we have the less than or equal to symbol and the greater than or equal to symbol. Those will always be represented on the number line with what we call a closed circle, which you'll see in 1 second when we do the example. The first one we're going to look at is they're asking us to plot this inequality right here. P is less than or equal to -2. So whenever you have to plot an inequality on a number line, the first thing that you do is you draw the circle on this number. Whatever the number is, we draw a circle. In this example, we're going to use a closed circle, which means the circle we drew on -2, we have to color in. Now the reason that we color it in is because the symbol is not just less than, but it's less than or equal to -2. So what that tells us is that P can be less than -2, but it can also be equal to -2. And that's why we have to color in the circle. Now we have to decide if I should shade to the right or to the left. And so you have to ask yourself, is the value of P to the right or to the left of -2? P is less than -2. The numbers that are less than -2 are this way. So we have to shade to the left. This closed circle will be used whenever you have less than or equal, or if you have greater than or equal. So basically, anytime you see a symbol with the line underneath, it has to be a closed circle. Because what that means is that that number, in this case -2, could be a value for P. Because P can be less than -2 or it can be equal to -2, and that's what the closed circle means. The other type of example that we're going to look at down below is a situation where we're going to have an open circle. So less than or greater than, those symbols will result in an open circle. So the first thing we do, plot x is greater than 5. So again, the beginning of this process is exactly the same. We draw a circle on 5, and now the symbol is just greater than. So x has to be greater than 5. It cannot be equal to 5, and so we cannot color in the circle. Then we ask ourselves, okay, where are the numbers greater than 5? The numbers greater than 5 are this way. So we have to color to the right. And you'll notice I put an arrow at the end of my shading. You should always put an arrow at the end of your shading because that indicates that the solutions continue in that direction. So now that we've discussed plotting our solutions on number lines, we did a couple of those. We'll get a lot more practice in the next few examples. But now we're going to discuss actually solving inequalities. And this statement right here, if we multiply or divide both sides of an inequality by a negative number, we have to switch the inequality symbol. Now switch the inequality symbol, that means if it was less than, we would change it to greater than. If it was less than or equal, we would change it to greater than or equal. So if you multiply or divide on both sides of an inequality by a negative number, that's when we have to switch the symbol. Other than that statement right there, everything else, the entire process for solving inequalities is exactly the same as what we've already learned for solving equations. So keeping in mind that the process to solve an inequality is exactly the same as solving an equation, we're going to draw our line and we can put y alone. The difference now is usually we would put y equals and then leave a space. After we do the work, we can fill in the answer. The symbol this time is not going to be equal. So right now we can put the y alone, but we can't write the symbol yet. The work we're going to do here to make y alone, just like an equation, we're trying to cancel out the -3. So we're going to divide both sides by -3. So 15 divided by -3 is -5. So we have y alone. We have our number on the right-hand side. Now what's different about these is it's not equals. This symbol was less than. Remember on the previous page, we talked about the only difference between solving inequalities and solving equations is that if we multiply or divide on both sides of the equal sign, or in this case, the less than symbol on both sides of the line, that's when we have to switch the symbol. So, did we multiply or divide by something negative? Yes, we did. We divided by -3. So what that means is the symbol was less than. In my solution, in my answer, it's going to be greater than. So my solution to this inequality is y is greater than -5. That's our solution. Now we have to plot it. We find -5, we put a circle. It's an open circle because the symbol is greater than. The value is greater than -5. You ask yourself, where are the numbers greater than -5? They're greater than -5 to the right, so I shade to the right, and I remember to put my arrow. Okay, another example. Y plus 2 is greater than or equal to -8. We draw the line. Again, I'm trying to make y alone. If this was an equation, how would we solve it? We have to cancel out the plus 2, so I would do -2 on both sides, cancel out. -8 plus -2 is -10. Now this one you have to be really careful. Now we have to decide about our symbol. The original symbol was greater than or equal. You ask yourself, what did I do on both sides? Did I multiply or divide both sides by a negative number? No, we didn't. We added a negative number to both sides. You only change it if you divided or multiplied by something negative. In this case, we added a negative number. So this greater than or equal symbol does not change. We bring it down exactly the same. So our solution is y is greater than or equal to -10. Now to do my number line, I draw a circle on -10. It's greater than or equal, so that means my circle needs to be closed, needs to be colored in. And the values greater than -10 are to the right. These are all the numbers that are greater than, bigger than -10. To solve this example, we draw the line. We need to get h alone. And in this case, the value that we need to cancel out here on the left is -1/2. That's being multiplied times h. So we have to multiply by the reciprocal. So we're going to multiply by 2 over -1 on both sides. These cancel out. I have my h alone. 3 becomes 3 over 1. Let's multiply. And now we multiply across. 3 times 2 is 6. Over 1 times -1 is -1. So my value on the right is -6. Now we have to, again, ask yourself, what did I do on both sides? Did I multiply or divide by something negative? Yes, we did. We multiplied on both sides by a negative value. And the key here is that it was multiplication. Multiply or divide by something negative. We multiplied by a negative value, so instead of less than or equal, we have to change it. Greater than or equal. So my solution is h is greater than or equal to -6. To plot my solution, I draw my circle. This one's going to be a closed circle. because it's greater than or equal to, and the values greater than or equal to -6 are to the right. So I shade to the right. So to solve this one, we draw a line. We're going to get b alone. To cancel out that 7, we have to do divided by 7 on both sides. These cancel out. -14 divided by 7 is -2. Now this one we have to be really careful. The solution, -2, we do not look at that number to help us decide if we should change the symbol or if we should leave it the same. The number that we look at is what I did on both sides. I divided by 7, +7. That means my symbol does not change. We keep it the same, less than. I draw my circle on -2. B is less than -2. The values less than -2 are to the left, so we shade to the left, and we always remember the arrow. So the final example that we're going to look at is a two-step inequality. So just like we did with equations, the first thing we have to do to solve a two-step inequality is add the opposite. So we have to do -4 on both sides. We bring down -2m. -10 plus -4 is -14. Now you ask yourself, did I multiply or divide on both sides by something negative? No, you did not. We added something negative. If you add or subtract, the inequality symbol will never change. So in a two-step equation, in step number 1, it's never going to change. You don't even have to worry about it. You should copy down the same symbol. Now we continue our process. The next thing we have to do is cancel out the -2. The way we do it, because that's multiplication, is we divide by -2 on both sides. So -14 divided by -2 is 7. Now again, we have to think about the symbol. Every step we have to think about if I should keep the symbol the same or change it. In this case, we divided on both sides by a -2. Because we divided by something negative, instead of less than, I'm going to change my symbol to greater than. So my solution is m is greater than 7. So I draw my open circle on 7. M is greater than 7. Where are the numbers bigger than 7? Where are the numbers greater than 7? The numbers greater than 7 are to the right. And we always remember the arrow.